You loaded all your company docs into an AI. A customer asks a simple question in their own words, and it still can't find the right file. The problem isn't the AI, it's how it searches. Old school search matches words. You type late delivery, it hunts for those exact words. If your document says shipping delays, it finds nothing. It's the same meaning, but obviously different words. Embeddings fix that by searching for meaning instead. Here's the one idea to hold on to. An embedding turns a piece of text into a location, a point on a giant map of meaning. Things that mean similar things get placed close together on that map. Late delivery and shipping delays end up as near neighbours, even though they share no words. So finding the right document stops being about matching letters, it becomes about finding the nearest point on the map. That's the whole trick. The text goes in, a location comes out, and closeness equals relevance. It sounds abstract, so let's make it something that you can picture. Think of a really good librarian. A bad librarian shelves on title, alphabetical, rigid. If you ask for a book on dogs, and if the title says canines, they shrug. A great librarian, however, shelves by what things are about. All the dog books sit together, whatever the cover says. Whether it's puppies, hounds, canines, they all sit in the same corner. Embeddings are that great librarian. For every piece of text you own, each document gets placed on the shelf by its meaning, next to everything that's about the same thing. So when a question comes in, you don't scan every title. You walk to the right corner of the room and grab what's already sitting there. That corner of the room is really a neighbourhood on the map of meaning, and finding it is fast, even across millions of documents. Now, how does text actually become a location? That's the mechanism. Here's the pipeline from start to finish. Step 1. Every document you own is run through an embedding model. Out comes a long list of numbers. Think of it as coordinates. Not 2 coordinates like on a real map, but hundreds. Together, they pin that text to a precise spot in a space of meaning. Step 2. Those coordinates get stored, often in something called a vector database, which is just a filing system built to answer one question fast. What's nearest to this point? Step 3. A question arrives. You run it through the same embedding model, so the question becomes a point on the same map. Step 4. You look for the document points closest to the question's point, closest in meaning. Those nearest neighbours are your relevant documents. That's it. Text to coordinates, coordinates to nearest neighbours to answers. The jargon, embeddings, vectors, semantic search all describes this one move. Turn meaning into distance, then measure it. And crucially, nowhere in there did it match a single keyword. It matched position. That's why it finds shipping delays from late delivery without being told that they're actually related. Let's run it through a support bot over your help center. Setup happens once. Every help article gets embedded and stored. Your refund policy, your shipping page, your returns guide. Each becomes a point on the map. That's your searchable library. Now a customer types, "My order still hasn't turned up." Watch what happens. First, that sentence gets embedded, turned into a point on the same map. Secondly, the system looks for the nearest article points. The closest one isn't titled "Order not turned up," it's your shipping delays. Because in meaning space, they're neighbours. 3. That article gets handed to the AI, which reads it and writes a plan answer grounded in your actual policy. The customer used words that appear nowhere in your document. Keyword search would have returned no results. Embeddings returned the right page. And there's the connection to something you might already know. This is the retrieval half of RAG. When we said RAG lets the AI read your files before answering, embeddings are how it finds which files to read. The same trick powers product search that understands something warm for winter and finding the one relevant clause in a 200-page contract. Now, the honest limits, because nearest is not the same as right. 1. Near in meaning, not in truth. It returns the closest text it has. If none of your docs actually answer the question, it'll still hand over the closest one, and a confident wrong answer follows. 2. Garbage in, garbage out. If your docs are outdated, duplicated, or contradictory, embeddings faithfully retrieve the mess. It's a great librarian for a badly stocked library. 3. Chunking matters. Documents get sliced into pieces before embedding. Slice them badly, mid-sentence, too big, too small, and the right answer gets split across 2 chunks and is missed. 4. It finds, it doesn't judge. Embedding surface candidates, deciding which is actually correct still needs the model on top, and often a human. None of these break the idea. They're all reasons to keep the library clean and up to date. So when should you care about this? Reach for embeddings the moment you want AI to answer over your own content. Support docs, knowledge base, past tickets, a contract library. Anytime, search that actually understands the question would help. A few practical calls. Keep the library clean. Dedupe, remove the sale stuff, and chunk documents into sensible, self-contained pieces. Retrieval quality is capped by document quality. Pair it with the model. Embeddings find. The language model phrases the answer and cites the source. Neither does the whole job alone. Build versus buy. You can stand up a vector database yourself or use a tool that hides all of this behind a search box. For most businesses, the managed option is fine. What matters is that you know what's happening underneath, so you can tell a good one from a gimmick. The takeaway isn't go and build a vector database. It's when a vendor says AI-powered search, you know the engine and the right questions to ask about it. 3 things to take with you. 1. An embedding turns text into a location on a map of meaning. Similar meanings sit close together. 2. To find the right document, the AI embeds your question and grabs the nearest points. Meaning, not keywords. 3. It finds related, not guaranteed right. So keep your documents clean and let the model and a human do the judging. You've now got the piece under Smart Search and RAG. Next, what happens when AI stops just finding things and starts doing them for you? That's agents.